Hey everyone, it's Norm from Tested. Happy Friday. Hope you've been having a wonderful week. We've been having a lot of fun here on the channel, and I want to wrap up this week with another miniatures lighting project, something I've been tinkering with for the past few weeks. I think I'm finally ready to share. If you've been watching my videos, you'll know that over the past couple months, I've been obsessed with different types of LED lighting and different form factors that LED lighting now comes in, not just rolls of LED strips with the sticky backing that you might, put on your walls or your cabinets or shelves. That's all fine, and there's lots of variety there, but also new form factors like LED filament strands, the things you might find inside those fake Edison bulbs that are actually LED tubes inside a glass bulb. And a couple weeks ago, I used silicone encased LED strands to make a Blade Runner inspired faux neon sign at 1/6 scale. And in the making of that project, I really fell in love with those silicone strands. They're not the easiest to work with, but they provide great illumination, run off of 3 volts, and I saw a lot of opportunity to take that form factor and really have fun with it. So I started thinking, what else could I do with these strands? And a new project came to mind. You may have seen very popular over the past couple of years, a type of LED tube light that's been used maybe for photography or stage shows, concerts, music videos for sure. A company called Quasar Science makes these, and there are a lot of other companies and DIY versions, but essentially they look like 3 or 4 foot long fluorescent tubes. You can have them freestanding, mounted in walls, interesting arrangements, but they cast a really nice glow, and when used in a big production environment with fog, for example, it can add a lot of depth to the scene. And I was starting to wonder, well, could I find a way to have a miniature version, a 1/6 scale version of that type of LED tube? And the first thing I thought to, well, I've experimented with some neon tubes for real neon tubes. There's stuff like this. This is the kind of LED tube, neon tube, sorry, that I had used last year to make miniature lightsabers. And they're CCFL tubes, super affordable, reliable, and they run off of a couple AA's through an inverter and cast a really nice glow, come in a variety of colors, blue, green, red, which makes them really perfect for tiny lightsabers. And while they're not too difficult to work with. You have to remove them from this plastic housing, maybe do a little bit of rewiring. You can't get away from having to use an inverter box here, which complicates the wiring process. There's typically 2 that you can light up with one of these because it runs at a relatively high voltage. So not the most ideal if I want to have a bunch of them set up. Certainly doable, but I wanted to see, can I make an LED version of this? And so one thing I came up with was taking that LED filament strand and maybe encasing it in something or kind of wiring it in a way to simulate a fixed tube. And this is what I came up with. Now this is just a 2-inch piece of that LED filament wire, exactly what you'd find if you took apart a fake Edison bulb and desoldered the edges, or you can buy them in bulk just in this strand. And if you see what I have it, instead of wiring the top and bottom with thin wire, it's actually connected using some copper rods, bent copper rods, and bent in a way that this can be freestanding. So this kind of gives me that illusion of a LED tube light, maybe on a tiny monopod, except it's just the copper rod. And I'll give you a little bit of a demonstration. Let's see if I can get some power onto this. And yeah, it gets pretty bright. This one's just the white light. The wiring works and it runs off of 3 volts, which I could then maybe wire in parallel. And The only thing I wasn't happy with was actually the scale of this. This being about 2 inches, it kind of works at maybe 1/12 scale, maybe even 1/8 scale, but at 1/6 scale, it's, it would be the equivalent of maybe a foot and a half or so. So I wanted to find something that was larger, and unfortunately with these LED filament strands, you can't cut them to length. They are fixed length. But thankfully, you can get them at a foot long. You can even get them at like, I think 3 feet long at most. That runs on 24 volts. This is about 2 inches. I needed something that was more of a sweet spot. And what I ended up finding was something that I think is gonna be perfect. Something that's 130 millimeters long, 13 centimeters in this flexible LED strand. So again, this is encased in silicone. There's a little indicator on one side for the positive, and then the other side is the ground. All the electronics are embedded in here and well hidden, and it's relatively durable. Can't cut it to length again, but see if I wire this up to the power supply at 3 volts, again, really, really bright. You can adjust the voltage a little bit to dim it. So here's at 2.7, 2.6 volts, and still casts a nice glow. Flexible, and the flexibility is not necessarily a benefit here because I want something that emulates a solid rod. And I actually ended up making something like this. Now, before I wire this up to show it lit up, let's walk through how I actually got to this form factor because it introduces some new materials and techniques that Adam showed me that made the whole wiring of this so much easier. Okay, let's take a look of our bill of materials. We're going to start off, of course, with our LED filament strand here. This one at 13 centimeters or a little over 5 inches, which is going to be perfect for our 1/6 scale. They come in a variety of colors. This one is warm white, but they do have blue, green, red, cold white is what I found as well, and they run at 3 volts. So you have to wire positive and ground, and one side has a little bit of an indentation, which tells you that's the positive lead. Now, to get this to look like a fixed LED tube, I needed something to make it, solid and rigid, and for that, we're just going to use a clear plastic stirring straw. Found these in bulk. The interior diameter ended up being perfect to fit one of these strands, and lengthwise, it's just a little bit longer than we need. So again, really, really optimal, just a perfect happenstance that this ends up being a perfect match, as you'll soon see. To wire up, we're not using wire. We're going to use copper rod. I was looking around to see could I find what's the thinnest but still sturdy copper rod I could find. What's a high gauge equivalent of copper rod? And this is 1 millimeter in diameter. So very malleable, easy to bend with your hand if you want to. We're going to use this jeweler's tool here to bend it, and I found this in about 16 inches in length. What's interesting is that this actually has, I think it's actually has a hole in the center, so it actually is hollow, which is amazing how this can be manufactured. But this will run our power as well as being our structural support. And then a variety of other tools as well in terms of some nippers, wire cutters, and this jeweler's rod bending tool, tweezers as well. So the first thing we're going to do is we're going to cut a little bit off of this straw because as I've been working on this, it is maybe 1 centimeter too long. So we're going to cut that off, toss that to the side, and then this is a little bit of a delicate process. We're gonna wire this strand through the straw. The silicone can get a little bit sticky toward the end of it, but yeah, once you get to the end, what I end up doing is getting some fine tip tweezers and then pulling out the contact from one side. There it goes. So you can see now I have my metal contacts exposed on each side, and we've essentially turned that flexible silicone strand into a solid tube. Now, we'll do a little bit of a test to make sure that the strand is working, and you'll get a sense of how bright that is and what our tube might end up looking like. So already looking a little bit like a different, we've already transformed that strand into like a tiny tube. I think it's already super neat. Okay, so next up, we're gonna cut some of this copper rod to length. The idea is we're gonna have one end connect to the bottom and become a stand, and the other end will connect to the top, run all the way the length to the bottom, and then become part of the stand as well. So we need a shorter side and a longer side. It'll be about, let's say, 4 or 5 inches here for the bottom side, and we'll just snip that. Not being super precise in this demonstration, but a shorter side, that's the bottom, and a longer side, that's the top. The next thing would be to solder these pieces together. Now, here's a confession. I am not good at soldering. I really almost loathe the process sometimes. You know, I'm either out of flux or, you know, I'm just not very good at it. So I've been looking for ways to simplify that wiring process while still having the strength of a soldered connection. And something that Adam recently shared with me was this solder seal wire connector pack. Pop this open. It comes in different gauges, but essentially what you have is heat shrink tubing and low temp solder embedded in this small little bit of heat shrink tubing. And they go from really thick to really high gauge, really thin here. We're going to use something right in the middle. And this ended up being a huge time saver and just a super satisfying thing to use. This is like the magic of this project. I have 2 pieces here. Again, we'll take a look at the anatomy here. It's heat shrink tubing. There, where this red color is, that tightens up just a little bit. So if you have wire, this is what's designed for, wire on each side, the heat shrink will kind of lock the wire on both sides. And right there in the center, that's low temp solder. That melts under the heat of a heat gun. And then with your exposed wire, that'll actually then lock the whole thing and becomes a relatively secure connection. We don't even need it to be a massively secure connection with what we're doing. We just need it to be simple and easy to use. So again, perfect happenstance with the diameter of this straw and the silicone wire, as well as this heat shrink solder seal connector. I can actually plug that right over. You can see it fits right over the strand. And if I push that just a little bit in, I want to make sure that solder is covering the connector and not bending it as I've just done. Oh, it's actually a really tight connection here. I'm going to snip off this end a little bit. So you don't need that. And what's important is I want to make sure that exposed metal contact is being covered by the solder. And I've bent it a little here, so I'm going to use my tweezers just to straighten that out a little bit and even pull that just a little bit up. Wonderful. So you got silicone strand, straw, and heat shrink tubing, as well as the solder there. And let's just connect it to this copper wire. The idea is I want to keep it as straight as possible. So I have some helping hands here. Lower that so you can see. And then we're just going to place that heat shrink tubing right over and making sure the copper rod, the low temp solder, and the exposed metal contact, that's all overlapping right under the center here. And then we take a heat gun and apply some heat. You can see that heat shrink tubing has wrapped itself around the copper rod, and when that solder melts, you can actually see it almost collapse and turn into liquid. It's quickly drying right now. I'm going to let this solidify. So wait a couple seconds or so until this becomes a stable, solid, single structure. All right, let's take a look. And at this point, this is a single unit. We're going to test it, of course, to make sure the connection worked. And it did. Awesome. And now we're going to go bend the bottom copper rod here into a little bit of a display stand. All right, so using this bending tool, wire bending tool, we're just going to do this manually. I don't have a jig or anything. And the important thing here is keep everything perpendicular and bent at right angles. I've done this a couple times now, so I have my process locked down, but of course you can develop your own. All right, we have a little bit of freestanding structure. There's a little bit of room to do some final tweaking to make sure it is standing up vertically, as vertically as I can get it. And let's go one more time, just to give it some extra stability. There it goes. Now bend a little bit of this copper rod up. Maybe snip this right here. And we have one end of our little lighting tube wired. We're going to do the same thing for the top here. So again, using this heat shrink solder seal connector, making sure that's properly overlapped right there. I'm going to snip off the top since we don't need that heat shrink tubing for the copper wire. And then for our longer rod here, what I'm going to do is use the wire bending tool and create a little bit of a hook at the top. It's a tiny little hook right there, and that will hook right into the top and again overlap with the heat shrink tubing, the low temp solder, as well as the metal contact at the top of that LED silicone strand. It's really cool to watch this low temp solder work. I mean, you don't have to have a soldering iron at 300 degrees or so. You can just use an off-the-shelf heat gun. It's a little safer. The connection is solid. I mean, this is not going to endure a lot of stress, and it just allows me to work so much faster without all the fumes, of course, also of soldering. It's really quick to solidify. Of course, it's important not to have your positive and ground rods here touch, and so I've oriented it so there's a little bit of a gap, a little bit of a distance, and then we're going to do one more bend on here for our positive lead. All right, so now we have our completed miniature LED tube. That's actually an LED light, but now here the 1/6 scale equivalent. And as you can see, it's freestanding. And if we do a power test, the way I've wired it, again, ground, positive, and at about, that's what is this, 2.5 volts? Let's bump it up to 2.8 or so. There it goes. It gets really, really bright, and I can have, well, maybe a bunch of these. So this past couple days, I've been spending some time making a few of these, experimenting with bending the copper rod a couple different ways to have it freestanding. But to wrap things up, let's take all this up to a photo studio, get them wired up, grab, I think I have the perfect 6 scale figure to pair with these, and grab some photos and video. This should be fun.